guess we can get started. So my name is Katelyn Wolf. I'm presenting my capstone project where I performed a landslide hazard risk assessment for Los Angeles County, California. Okay, there we go. So starting off, what is a landslide? So according to the U.S. Geological Survey, it's the movement of rock, debris, and earth down a slope. It can have a variety of different causes, but most commonly there's increased precipitation, drought, wildfires, reduced vegetation, and steep terrain. So the precipitation and drought, if it hasn't rained in a while and it suddenly starts to rain again, it will displace the soil instead of absorbing into the soil if the soil is too dry, which causes that runoff, which can cause a landslide. And then the wildfires and reduced vegetation. Typically for vegetation, the root system helps to hold the soil in place. So wildfires have recently burned up the vegetation and gotten rid of those root systems. The soil, the structural integrity is going to be weaker. And then I think the steep terrain is fairly self-explanatory. If it's sloping downward, things are going to run downhill. So for my study area, I chose Los Angeles County, California. And I chose it because it has a variety of climate factors, which I'm going to discuss in the next slide, that make it particularly susceptible to this sort of climatic event. And then it also has a high population density, which means a lot of people are going to be affected by these events. So LA County has approximately 10 million residents, which is about 27% of California's total population. And it is made up of the city of Los Angeles and then the surrounding suburbs. So the climate's primarily arid, which means it has warmer temperatures year-round and lower precipitation. It also experiences frequent wildfires because of these factors. It's very dry in the summer. It also has a fairly mountainous terrain with steep slopes surrounding the city of Los Angeles. It's also along the coast, so along the Pacific coast of the United States, and it's also located along a fault line, which means it's particularly susceptible to seismic activity. So the purpose of the study was to perform a landslide risk assessment for Los Angeles County, and this would allow us to identify high-risk communities, so communities that are have a high likelihood of being affected by a landslide event. Allow for these communities to better prepare for the potential disaster and mitigate the effects. Also, this would help to advise developers on where to build out future communities, because if there's a certain plot of land that's going to be repeatedly hit by landslides, it would be bad for the residents and the developers to build out the community in that area. And then finally, this would hopefully inform the government where to allocate resources for emergency disaster preparedness measures to prepare those communities, and also make sure that the government has the infrastructure in place to help these communities in the event of a landslide. So I'm going to briefly go over the data sets that I used. So the first data set was the Wildlife Perimeters data set, which was from the National Interagency Fire Center from their open data site, and it shows past reported wildfires up and including 2021, the year of 2021, and it shows just the perimeters of the areas affected by those wildfires. So this data set was for the entirety of the United States, but for the sake of producing a comprehensible map, I just showed the California region, and that's pretty much all we're going to be focusing on. So the other data set that I used was a digital elevation model, which was from the U.S. Geological Survey's Earth Explorer. It's a Landsat 8, and it's made up of 4 different TIFF files, TIFF files that make up the DEM. So this will be used to calculate slope and aspect and see different changes in elevation. I also used a data set that showed the average annual precipitation for California. This was part of a larger data set that I believe the data starts in around 1950 and it actually goes out to like 2050, where they have the actual data up until the present date, and then they push out, or they have a predicted model for every subsequent year that hasn't happened yet, and they update it then with the current data. So I just pulled out the data for 2022 because that was the most recent data they had. Yeah. And then the last data set I used was NAIP imagery for 2020. Yeah, 2020. It's natural color. This was used to calculate the land cover, land use raster. And you can see there's certain areas where there's no imagery, and that's for top secret, like government and military facilities. They just don't have the imagery published for that, understandably. So if you see any holes in the data set, that's why. So moving on to methodology, I have a more detailed flow chart here, but just a general overview, I clipped each layer to LA County so that it was only showing for that specific study area. Based on the DEM, I calculated the slope and aspect layers using the slope and aspect tools. And then for the image, I performed imagery classification on the NAIP imagery to get the land cover for LA County. Then I used the slope, land cover, and precipitation layers to perform a weighted overlay analysis. Okay, so moving on to results. So this map is showing the slope layer that was calculated. So as you can see, the city of Los Angeles is pretty close to sea level. It's a lot flatter because it's an urban area. And the outskirts of the city are a lot more mountainous, have a lot steeper slopes, and just, more mountainous terrain. And you can also see that on the aspect layer here. This just allows you to better visualize the actual direction the mountain slopes are facing and all of that. And you can kind of see how it actually looks, not just how steep it is in each particular region. So you can see all of the mountain faces are kind of sloping down towards the city and the residential areas. So here's the land cover layer that I produced. I divided up into 4 categories, being water, urban, minimal to no vegetation, and vegetation. The minimal to no vegetation is just because it was hard to tell based on the imagery if an area was actually completely barren or if it had some small shrubs and brushes, or brush and that sort of thing. So based on those 4 categories, I classified the image using the image classification wizard in ArcGIS Pro. And you can see the coastline is primarily urban and vegetation. A lot of that's people's yards and like kind of landscaped greenery in the city. The Northeast region is a lot of minimal to no vegetation, a lot more arid and dry. The national forests understandably have high levels of vegetation, but you can see that throughout there's a lot more no vegetation area throughout, which could be the result of wildfires in these forests. Moving on to precipitation, you can see here the 2 national forests that I've highlighted, which are Los Padres National Forest and Angeles National Forest. Both have higher levels of precipitation than the rest of the county. Now, this is proportional because the entire county does have a fairly low level of precipitation on average when compared to the rest of the country. But yeah, these 2 national forests have proportionally higher levels of precipitation. And then for the wildfires, you can see those 2 national forests are hit pretty hard. They have large areas that have been affected by wildfires. And for this, I focused on wildfires from 2016 to 2021. That was the most recent data that they had. And I felt that that was more indicative of fires, or those were fires that would be having a more profound effect on the landscape than something that happened in the 90s or early 2000s. So I focused on those, but you can see both forests understandably are highly affected because they have a lot of fuel for the fires to burn. And then when you get to the city, it kind of tapers off. But yeah. So the weighted overlay analysis, this was based on precipitation, slope, and the land use rasters. All the variables were assigned to equal weight, since I believe that they have equal importance in potentially causing a landslide event. So the higher value indicates a higher risk of landslides. And the primary area of concern that was identified based off of this analysis was Angeles National Forest. There's high risk areas throughout, but that was the biggest cluster of, that dark red value, and it seemed to be hardest hit by all the different variables. So all of that accumulated to produce this map here. So this is the high-risk regions and cities that were determined based on the previous analysis. So the orange polygon shows the high-risk regions, and these regions are, this refers to regions that are likely to have a landslide occur there. And then the yellow dots are high-risk cities, and these are cities that are in the pathway of landslides or are likely to be affected by the after effects or the runoff and debris flow of the landslides. So these are all located directly beneath that higher risk area of the Angeles National Forest. And so they're directly in the path of that debris. And I didn't even list the cities out. The cities are La Canada, Flint Ridge, Pasadena, Arcadia, and Glendora. So these are like highly populated residential areas directly beneath the slopes of the mountains that are in Angeles National Forest. So there's a couple proposed solutions based on these results. The first one is to improve drainage routes for runoff. So this would allow drainage routes to be built out so that if there was debris flow and runoff, it would flow away from residential or community areas and hopefully mitigate the damage. The second proposed solution is to build debris catches along major roads, and this would protect evacuation routes, and it would also allow first responders to get to communities that have been affected faster without their path being blocked by debris and runoff from the landslide. The third solution is to stabilize slopes by planting a vegetation cover. So this is a more long-term solution because the plants would need to form deeper root systems, but this would improve the structural integrity of slopes, especially those that are surrounding roadways or residential communities. And then finally, the last proposed solution is to update and publicize emergency guidelines for residents. This would primarily be done by governments, both state and local governments, and that way residents would be prepared to either evacuate or to take steps prior to an event to make sure that their residents, their house, their neighborhood is just more protected and that they're aware of the risks associated with where they live. So in conclusion, the most at-risk communities were identified as La Canada, Flint Ridge, Pasadena, Arcadia, and Glendora, which aligns with findings from existing literature. And hopefully using these findings, governments and communities can take precautionary measures to mitigate the potential impacts of landslides and potentially perform further research to further identify at-risk regions, areas, and just make their communities safer and protect the infrastructure and toll on human life that can occur due to landslide events. And that's it. Thank you.